Now that we can simplify radicals, we're ready to do more advanced multiplication with radicals, although not the most advanced, but we're getting there. And as you can see, I wrote this sheet just for you. The rules for radicals or roots, depending on what you want to call them, make sense because they're in the multiplication family. The same logic that allowed us to break up rad 18 into two pieces so that rad 9 could be simplified and be evaluated as a 3, the same rules allowed us to do any kind of multiplication that we want. And not just for square roots, which is what we're going to focus on here, but for cube roots, fourth roots, any root you want. So anything that involves multiplication, including exponents, anything that involves division, which is in the multiplication family, including fractions, which I didn't focus on this sheet, you find the answers by just connecting the numbers using simple multiplication. So of course I started out with reminding you about simplifying a single radical. Rad 18 is 3 rad 2. And of course it's incredibly annoying that I notice every little thing that bothers me in the middle of making a video and not when I wrote the sheet in the first place. Did you notice how 3 rad 2 had no dot between the 3 and the 2? But over here, which we'll get to later, in the 4 rad 3, there's a dot between the 4 and the 3. The dot shows you the multiplication that connected the 2 times 2 in this problem, but I didn't put it here and I didn't put it here, so why did I put it there? Maybe I'll say that it's a teaching opportunity to show you that if you want to put the dot in, because multiplication is what connects the 4 and the rad 3, then you're allowed to if you want to, or you can leave it out and it's understood. Moving right along, I also made an example by showing you how multiplication allowed you to split rad 72 into 9 and 8, and then the 8 split again into 4 and 2. The rad 9 made a 3, the rad 4 made a 2, and there's your rad 72 equaling 6 rad 2. However, you can make your simplified problems more interesting by including extra multiplication in them. Notice that the instructions don't change. It says simplify, but as you'll see in the next example, that doesn't involve more multiplication. Move back up to the top of the page and my annoying little dot rant that I did before. Now I'm going to put a 2 in front of the rad 12. Rad 18 didn't have a number in front of it. Rad 72 didn't have a number in front of it, but it is allowed to put a number in front of a radical. Radical is a number. You can put a 2 in front of it the same way you can put a 2 in front of an x and write 2x. The 2 is a whole number, and because it's attached by multiplication, I'm going to be able to continue the multiplication with any number that comes out of it. So when I split rad 12 into rad 4 times rad 3, the 2 that rad 4 makes is now going to be connected by multiplication to the 2 that was there originally. The rad 3, of course, the line shows you over here that rad 3 has no perfect squares in it, and so it's done. So 2 rad 12 has the exact same decimal as 4 rad 3 with or without the dot. All right, I'm going to get over it eventually. Moving along to number 4, what if you want to multiply 2 single radicals? What if in front of one radical is another radical? Well, the same way you can split radicals, you can multiply them together. So a rad 12 times a rad 2 makes a rad 24, because a regular 2 times a regular 12, times a regular 2 makes a regular 24. So if they're square root category, then they make a square root. Once the rad 12 and the rad 2 are rad 24, I now have an opportunity to split them in a better way than they were theoretically split before, with the rad 4 in front and the rad 6 afterwards. And therefore 2 rad 6 is the final answer for this multiplication example. For those of you who like to fish or do other shortcuts, please continue to do so. However, for those of you who want to keep it simple and follow the same rules all the time so that you don't have to be confused or annoyed, the rule is take 2 multiplication radicals, make 1 big multiplication radical, and make a tree the same way you did over here if necessary, and the same way you did over here, except we can't see it anymore on the screen. Whenever you do a multiplication problem with radicals, keep in mind that you're uniting numbers that are like cousins who play together. Radicals are in the multiplication family, multiplication is in the multiplication family, so everybody gets to play together nicely. That's not going to happen in addition, but that's a different sheet. Getting progressively more challenging, it's possible to multiply two radicals where there's a number in front of each radical. Again, all you have to do is be organized. Realize that the 2 in front of the rad 12 and the 3 in front of the rad 2 are whole numbers. And when we make one big multiplication example out of this, the whole numbers, the 2 and the 3, are going to want to make 6 together, while the rad 12 and the rad 2 are stuck being rads. Once that's done, the rad 24 splits the same way it did before, except now that the whole 2, that came from the rad 4 is going to multiply with the 6 that came from here and here and make a grand number of 12. So the final answer to this multiplication example is 12 rad 6. If you square a radical with a number before the radical, if you want to simplify 3 rad 2, all you have to do, if we're keeping it simple, and I should stop and move this page up, shouldn't I? That's better. If I want to simplify 3 rad 2 squared, and I'm keeping it simple, I'm going to rewrite it as 3 rad 2 times 3 rad 2. 3 times 3 makes 9, and rad 2 times rad 2 makes rad 4, except rad 4 makes a whole 2, and there's no more radical. Oh my. The answer is 18. 3 rad 2 squared is 18. And again, as we saw in class with Michael's explanation and with other explanations, you can get 18 faster, but who wants to be fast when it's easier to be simple and right and not annoyed? There are shortcuts you can use, as I said before, and if you like using them, please go ahead and do so. However, if you want to be familiar and comfortable, then in any multiplication problem, all you have to do is multiply any of the regular numbers in front of the radicals together and multiply the radical numbers together into one big radical. Make a tree for your big radical using simple, famous, perfect squares, even if it takes more than one set of branches to finish. And then when you're all finished, multiply all the regular numbers, that you started with, and all the regular numbers you made in your tree, and any radical stays a radical. The last thing we have to look at when we're doing radical multiplication is when variables are involved. And remember, when we're multiplying regular variables, then x to the p power times x to the q power will give you x to the p plus q power. When the same bases multiply, exponents add. And if these are inside radicals, then the x to the p plus q will be inside a radical. And remember the rule for roots of monomials, the opposite or the reverse of power to power exponents multiply is that root to power exponents divide. And square roots have root 2. So when we're multiplying two radicals with monomial radicans, meaning monomials inside the radical, let's check out what we do. Here's example number 7. I put a 2 in front of a radical with a 12x fifth. I put a 3 inside of a radical with 2x ninth. And when I multiplied the 2 together, oh my gosh, I lost the 2. I'm not redoing a whole video for a 2, but please put the 2 in yourself and imagine that it's there. See the 2? It got lost. It's so sad. So the 2 that's not here times the 3 that is here made the 6 that's supposed to be there. And the 12 times 2 made 24, and the x fifth times x ninth made 9 plus 5 is 14. So now I have a 6 on the outside, I have a rad 24 numerical, and I have a rad x 14th, algebraic. I split the 24 the same way I always do into rad 4, rad 6, the 6 that's in front of here, and the 2 that's over here, make the 12. The x 14, because 2 is the index, the number of the radical, did 14 divided by 2 is 7, and that moved to the front because it's whole, so to speak. And the poor widow rad 6 that's still in prison ends up on the end. So we reorganized it with the number that we started with, the number that came out of the radical, making a whole 12. The perfect x7 moving in front because it's better. Radicals go on strike. And the rad 6 that there's nothing we can do with, bad hair day for rad 6, is still over here. This is as bad as it gets for now, and you'll notice that I'm evil, so I put a negative sign in front of the 5, and all that does is make the product of negative 5 and 4 negative 20. Oops, I helped you. See if you can work this out. As you can see, the answer as promised is on the bottom. If you need help with this answer, please let me know. It is possible I made the mistake, in which case you get your name on the sheet, or if not, you can ask me or you can ask a friend. So now we've pretty much covered the rules for multiplication of radicals, and you can see that as bad as it gets, it's the same rules over and over and over again, and you don't have to learn a million things, you only have to learn a few things and just keep practicing them and being very organized. The next thing we have to work on is addition of radicals, which is different because addition is not in the same family as multiplication, and therefore radicals and addition don't mix as freely or as easily as multiplication does, as you can see back up over here. And so that's for another sheet where we have to learn to combine like terms. But before we can get like terms, we have to learn how to simplify each piece of the addition problem before we can look to see if anything matches. Aren't you eager to learn something new? Well, lie to me anyway.